So why serverless, and what does serverless mean? So serverless doesn't mean there's no servers. It just means that you don't have to actually manage the servers at all. Like you just give it code, or you tell it what you want to do through the Amazon Web Services console, and you don't have to manage the updates or anything that goes wrong with the servers. It'll just work. So it reduces your IT. You put off your IT to Amazon. Scaling is simple and precise, so you only pay for what you use. So in the past, you had to, if you thought you were going to have X amount of traffic on one day and then a spike the next, you had to plan for that spike. But with serverless, it'll automatically scale to that spike and scale down to however low it needs to go. So you only pay for the amount of actual compute time you use. And the decoupled architecture keeps you agile. So instead of having a monolithic server, you have a separation of responsibility into the web services. And then you can just plug and play those web services. So instance, you could switch the database, you can switch how the Lambdas work. So in this particular case, what is the serverless stack for a website that has a database backend? So Amazon has a cool DNS server called Route 53, which you can plug in your domain name into, and it will handle all the routing into redirect to CloudFront. This is the next step, and that's a CDN, and it provides HTTPS as well. You can add your own SSL certificates in there or generate them from Amazon. And then we have S3, where you can host static web content. So S3 can act as your website. You can have HTML, CSS, images, JavaScript, and you can host it directly from there. I'm going to show you guys how to do that today. DynamoDB or RDS provides a database. This is another web service by Amazon. DynamoDB is super cheap. RDS is the more traditional databases like SQL Server, MySQL, and the other guys. API gateway. Basically, you can design and build REST endpoints that interact with other web services or other HTTP endpoints. And that allows you to hook into Lambdas, which is really the linchpin of the serverless stack. That lets you execute actual code that doesn't need an actual server to run. And this is the Lambda symbol. So Lambdas, once Lambdas came along, that was the final piece of the puzzle. It means you can spin up and spin down instances without any kind of configuration whatsoever. So what we're going to do is a voting app. I'm going to show you guys how to build a simple voting app. Final product is going to look like this. It's going to have a voting form. You can submit your vote and then a results bar graph. So the first piece of the puzzle is to set up DynamoDB. So we're going to create a table in DynamoDB. So I've logged into AWS, and this is a fresh AWS for this project. I'm going to jump over to DynamoDB. So when you go to DynamoDB and you don't have any tables, it'll present you with this screen. Press Create Table, and I'm just going to create a vote tally table. And it'll be a primary key on the candidate. The DynamoDB cost is mainly based on this provision capacity down here, and that's basically how many reads and writes per second you can handle. Since this is a small app, and you see 5 reads and 5 writes would cost $291 per month. DynamoDB is also the most expensive part of this whole serverless infrastructure. But we switch these to 1 read and 1 write, which is plenty for this demo. So you see we have no items in here, and the only column we have is the candidate column. So now we're going to set up the Lambda function that records the vote from API Gateway into DynamoDB. So we're going to go create a Lambda. So this is the one we want, our microservice HTTP endpoint. So we can give it an API name, we can do a deployment stage, and we can set up security. So this is all the API gateway settings. So we're going to give it a name, and then we'll leave the deployment stage as prod, and then we'll just open up the security. So the default code for that blueprint is a method to modify and read a DynamoDB database. But we're going to change this to some custom code. This will be the vote caster. So when a vote comes in from the website, we're going to read it into this Lambda and then put it into DynamoDB. So this Lambda logs the event that's received, has a method for the callback that just sends a status code, the body, and the headers, which is an HTTP response that the API gateway can handle. And then it processes the post HTTP method to cast a vote. The cast vote method just looks like this up here. It takes the payload. If it's a string, it turns it into JSON. If it takes the vote as the candidate for the key for the DynamoDB params, has the table name, and then it just adds 1 to the vote of that candidate. And then actual call is right here. So it just updates the item with those parameters, and then it handles the callback, and then sends that callback on to the API gateway. So here we have to give our Lambda a role. So there's going to be a service role in there that we're going to give it. So the default one is this simple microservice, which is fine for now. We'll modify it later. I lowered this to 128 megabytes. So Lambdas, you get charged per 100 milliseconds times the amount of megabytes you use in memory. The memory determines how much CPU you get as well. So the more memory you request in your Lambda, the faster the Lambda will run. You can also specify timeout on a Lambda. So Lambdas can run for a maximum of 5 minutes. After that, they're just shut down automatically. I'll go ahead and create this function. So we have all our code in here. We can test it, see if it's going to error out or not. It's just expecting a candidate in the vote body. So the event body is expecting its HTTP method and event body. So we can configure a test event, set the HTTP method to post, and then the body will contain our vote, and we'll just vote for Clint. And we can see if our Lambda worked down here. So we got a status code 204 returned here, which means it's successful. And we have this received event, and it shows us the JSON we just sent in, and then it says casting vote here, and it just shows you the params that are being sent to the update item for DynamoDB. Now if we go back over to DynamoDB, we can see that the item was written. So our vote tally table, go to items, and we see the candidate Clinton has a tally of 1 now. So that Lambda is done. So step 3 is to set up API gateway, so we can actually hit this endpoint and have the Lambda fire. So the endpoint provided by Lambda Blueprint is broken, and I looked it up online. It's been broken for a year now since it's been released. So the problem with it is the permissions from that blueprint don't get set up correctly. So we have to delete the endpoint and create one from scratch, which is okay because we want to learn all the pieces anyway. And the third step, we're going to create a body mapping template to transform form post into JSON. So let's move over to API gateway. we have our voting API, and we have this cast vote method. But we're going to go ahead and so we're going to create a resource. We're not going to configure it as a proxy resource. We're going to actually transform the request as it comes in. So we can do that form to JSON translation I was talking about, the integration request. Just call this vote. And we can enable API gateway cores. So now we have this vote resource. So it follows a REST interface where all the endpoints are resources, and then you can modify them using the methods on HTTP. This default options one is the cores that we set up. So this will just pass back the method response, which has all the course headers you need in order to access it from another site or from your JavaScript. So that's what that checkbox did for us. So now we're going to create a method on this resource, and we're just going to create a post. So we're going to hit a Lambda function. We're not going to use the Lambda proxy. We're going to transform the request as it comes in and hit that Lambda. The proxy just pushes the request with right into Lambda, but we're going to massage it before it goes in there. And I think we're in US West right now. We're in West 2? Yeah. And then the Lambda was called cast vote. So this is where the API gateway just sets up the permissions for invoking your Lambda. This doesn't happen with the blueprint. So the permissions are not set up correctly. So the next thing we're going to do is we're going to modify a couple things. The first thing we're going to do is the integration request. So down here we can manipulate the content as it comes in, so it comes into Lambda how we expect it to. So with this, you specify specific content types that you want to map. So we're going to do the application www and then form URL encoded. So this is asking you if you want to change your pass-through behavior. So this will say, do you want it to only handle this content type that you specified, or all the content types you're specifying the body mapping templates, or do you want to pass through everything else? So we want to handle JSON too, so we're just going to let anything go through otherwise. We're going to use over here. So this will take a form request and translate it into this JSON template. So down here we have a loop going through each of the form values and just creating a key val pair instead. Okay. So it's the second thing we're going to change. Right now it's returning a 200 status. So we're going to use a straight form post, which if the post is going to return 200 status, then the page is going to redirect to those post results. If we want to stop that from happening, one trick is to send a 204 response instead, and that will tell the page there's no content, so don't bother redirecting, just stay where you are. So we're going to add a 204 response. We just delete the 200 response because we're not going to use it. And then we have to go here too as well, add an integration response. We can, if we wanted to handle certain errors differently, we could use a regex to choose which error we want to map to what response. But by default, we're just going to send everything to 204 if it's not an error. So we have to delete the existing 200 before we can do that. So now our post is sending back a 204. We can go ahead and test this endpoint by hitting this test button here. And we can give it a request body. So if we wanted to do another vote, so again, all our Lambda is looking for is this HTTP method, and then a body with a vote key. So we'll throw a bone to Trump. And then we can see what the Lambda sent back. So successful completion, method complete with status 204. We can check our DynamoDB, refresh it, and we see now they're neck and neck. So now our vote endpoint is working. But it's not inside of our prod stage. You see our prod stage still has that old cast vote, and it has all the old methods in here. So this stage is not updated until we deploy what we've set up in the API gateway resources. And we do that just with action deploy API. And it'll ask you what stage you want to send it to, and then you can put a message in here. Then we can check our stage, and we see the votes here. And it'll give you a URL right here to test it out. So we could test this out externally with something like Postman. So let's try out our XWW form URL encoded body. So we'll move down the list. We'll vote for Johnson. And we have to put the vote endpoint on here. And we'll just send a post using the dub form URL encoded with a vote body. And we got 400 bad requests. I know what it is. I put a dash right here, so I had it incorrect right there. So let's go back to our voting API. Hit the resources, hit post, and this is an integration request. The body mapping templates. I had URL dash encoded. That's not what we needed. We needed URL encoded. Save. And then we deploy. We'll try it again. Still saying bad request, isn't it? Saying bad string. All right, so this is actually good. So Postman freaks out when it gets a 204 response because it doesn't know what to do next. So when it does this, this is actually the end. So we can check back in DynamoDB and make sure that Johnson made it in, which he did. So we set up the endpoint, we deleted the given endpoint, and we created one from scratch, that post method, and we created a body mapping template to transform. I had the dash in here, that's what threw me off. The request with the form URL encoded, and now we can move on to the next step. So next step is we're going to set up the S3 bucket to be a static hosting website. So we can create a bucket in here, just call it voting demo app. We'll just set up in US standard. And then we're going to go ahead into the properties and go to static website hosting. We can enable website hosting, and the two parameters we need to specify that we can specify are the index document and error document. So we just specify index.html here. We're not going to bother doing an error. And there's also some redirection rules you can mess with that we're not going to get into at this point. So now our voting demo app bucket is a HTTP endpoint. If we go to properties, we can see the actual URL. And right now it just says 403 forbidden. So our index.html doesn't exist, so we're going to go ahead and upload it. So I have index.html, style.css, and data.json. Now if we try to do this again, we still get an access denied. So even though we set up the bucket as a website, we still have to enable public permissions to our actual items. You can do that one by one, which is kind of tedious, and if you make any updates, you're going to have to redo it. Or you can make a bucket policy that will just enable get object access for everyone. So we go to permissions and then add bucket policy. We can use sample bucket policies. If we look at these, there's granting read-only permission to an anonymous user. And we just got to copy and paste this configuration into here. All this is saying is that it's going to add a permission that allows anyone get object access to our resource, which we then have to change example bucket to our voting demo app. And now we have our voting demo app website. It doesn't have the correct endpoints in here, so let's go ahead and fix that. So we're going to open up the HTML. Let's look at this for a second. So all this is a form with radio buttons that get stylized and a submit button. And then it shows results using a chart from D3. Now this is doing, it's just pulling from data.json to then build an SVG chart using D3. We'll get to API gateway and we'll get that URL. Let's go to voting API, stages, prod, and we'll grab this. And that should be all we need to change in here. So we've saved our index.html and we're going to re-upload it to our S3 bucket. So now we've finished setting up the S3 bucket. We enable static website hosting, we set the bucket policy to enable public access, and we upload the HTML files. So now the last piece is setting up this Lambda to create that data.json file. So this is going to be a Lambda that's triggered from the DynamoDB update that will then take that data, it'll read from the DynamoDB table, it'll scan it, and then write that, that JSON to a file in S3. So we're going to go back to Lambdas. So we're going to go ahead and set up the DynamoDB trigger here. We have the vote tally table. We're going to set the batch size to 1. So whenever an update's made, it'll just get sent immediately. And then you can set the starting position as either the trim horizon or the latest. So the way the DynamoDB trigger works is that when it gets an update, it'll send you the records that were actually sent to DynamoDB. You can use the trim horizon, which will give you the oldest or the next record available, or you can just do the latest record, so it'll, when there's a change, it'll just send you the most recent one. Since we don't care about those record streams, we're just going to get the latest one, and then we're just going to read all the data from the table. So we're doing the latest. And we go ahead and enable the trigger. So I'm going to use this code here. So this code is pretty simple. We have the same DynamoDB object we're using, and then we're going to use the S3 as well. So this is part of the AWS SDK. We don't need to include this AWS SDK in our package because that's provided by Lambda automatically. So the instances they give you have the AWS SDK already installed as a package, so you don't have to package that up. And all it's doing here is it's scanning the table, so it's getting all the results from the table, just the 4 candidates, and then it's writing the results to S3. So S3 is pretty cool because it acts like a file system, but really it's just a key value store. So you're just passing a bucket name and then a key, which is ultimately the file you see, and then you can just pass a string to fill that file. And you just call S3 upload, and it'll basically export that table directly to S3. So this is all you need to do to transfer a table from Dynamo to S3. We're going to go ahead and use the same role we created for the other Lambda, voter Lambda. We're going to keep it at 128 megabytes, and we're going to set it to 10 seconds and no VB. So for this Lambda, we're completely ignoring the event that's passed in, so we can test it with any kind of trigger right now. So we're going to go ahead and test it right here. And we should see an error. So here we see an access denied. So when we see this, this means that our permissions are not set up correctly. And if we look down here, we can see that S3 was the culprit. So what we need to do is we need to add S3 permissions to that role. So we go to Services, IAM. We find our roles, and we find our voter Lambda. We can attach another policy. We'll just give it S3 access. So we can give it full access. That's fine. Oh, yeah, that's right. So I have it pointing to my old bucket. I just need to update to the bucket we're actually using. So now our data.json file was written, and we can go check it out. So we go to S3. Go to Inverting Demo app. You can see the data.json file was written at 1934, which is the current time, 7:35. So we refresh this page, we see our results down here. That's the last piece, and we're done now. The API gateway is being hit. The Lambda function is fired to record the vote. It's recorded DynamoDB, which will trigger the next Lambda, which will create a data.json file in S3. And then the web app is refreshing every 3 seconds to see if that data.json file was changed. So if we go back to our web app, we can submit some votes. Sometimes the JavaScript is not robust enough to work correctly. If we press refresh here, it should show up. There they are. So we go ahead and vote some more, bring them out. There it goes. So it'll automatically refresh. If someone else votes on their computer, so go ahead and send in a vote, and we'll see that it'll update here as well. It's just pulling every 3 seconds, so it's live updating in a way.
Thank you for watching. If you have any questions, feel free to email me at danrusk@thorntech.com.